x equals 2. Tangent line is something that, well, even on like the part C of that first question, it was asking for a tangent line. A lot of you missed it, even though all the information that you needed was already there. So what we need for a tangent line of G, we need G of 2, right? That means we just need to plug in 2. So we got 2 times 2 minus 1, which is going to give us the square root of 3. So my point is 2 square root of 3. Whenever you're doing this, make sure that you're labeling everything. Most of you are doing okay on that. A few of you were not. Now, for this particular problem, g of x is the square root of 2x minus 1. We do not know how to find that by hand yet. So, since we don't know how to find that by hand yet, we would use our calculator to find g prime of 2. So if we are using our calculator, here, let me put that up. Let's see. Alright, so to use our calculator for this on the screen here. Okay, so for the calculator here, you're going to hit, you will hit F3, which is differentiate, F3, choose differentiate. You're going to type in the equation that you want to differentiate, which is the square root of 2x minus 1. Now, if you want, you can put your comma. So if you want, whenever you do a derivative, you got to put the comma and then the x. You can hit enter. It will give you the derivative. It will give you the equation of the derivative, and then you could plug it in. But if it's calculator active, then you're allowed to take the derivative with the calculator. So you could also just go ahead and plug in 2. So to do that, you use that line that I showed you guys the other day. It's right next to the 7, such that x equals 2, and it will go ahead and give you the slope. So you could write down as little as square root of 3 over 3. But if you want, you can do g prime of x is 1 over the square root of 2x minus 1, and then do g prime of 2 is 1 over the square root of 2 times 2 minus 1, which will give you 1 over the square root of 3. So these are like alternative options here. Why are those different? I got square root of 3 over 3 when I did it in the calculator. I got 1 over square root of 3.
Because you got it, because they took the square root out from the bottom to the top.
They did. They rationalized that denominator. They multiplied top and bottom by square root of 3. Do you have to do that? You do not. So if you do it this way, it is perfectly okay to use 1 over square root of 3 as your slope. So either one, these are equivalent to each other. You can use either one as your slope. Here, so you could use this or you could use this, depending on how you do that part. And so then it's wants the line, find the line tangent to the graph. So it's asking for the line. The line is where we do y equals, slope goes here, square root of 3 over 3, or 1 over square root of 3. Either one's fine. And we do x minus 2 plus the square root of 3 for that.
With it being free response, could you leave g prime with 2 as 1 over 2 times 2 minus 1?
Yes, you can. You could leave it as 1 over 2 times 2 minus 1. In that particular case, I probably wouldn't, because the you might copy it wrong. Like if you made it look like 2 plus 2 minus 1 or something, like if you copied something wrong or you left off parentheses or something. Since that is very simple to do, I would go ahead and make it square root of 3. But you don't have to simplify. You could leave it much more complicated. You could leave this as square root of 2 times 2 minus 1 up here for your point. But whenever it gets so jumbled like that, sometimes it's hard to get that right when you're doing that last part. My rule of thumb for responses, I simplify as long as I feel very confident in my ability to do that calculation. So whenever it's just basic addition and subtraction, I'd go ahead. If it is something that I feel less comfortable with, like simplifying a square root or something of that nature, I'm just going to leave it complicated for that.
The derivative of the square root, like 1 over square root, whatever.
If it is just a square root, usually, because that's really like it's to the 1/2 power. So whenever you multiply out front and subtract from the exponent, you will get to the negative 1/2 power, which is the square root on the bottom. This one in particular, in section 3.1, we will learn how to do that one by hand. We just haven't learned it yet because that has a different rule. That's got a chain rule that we have to be able to do. Okay, so C here, I haven't really got to the part where I'm grading these problems that you guys had, but it asked for h prime of 2. I did see some people are having trouble on this because I've graded part of the second question, but I haven't graded completely. In my opinion, your best bet on this is to take the derivative with f's and g's first. Okay, so you're going to have h prime of x is going to be this 2 right here. You can either keep it out front or you can group it with the f of x. It doesn't matter which one you do. I'm just going to kind of leave it out front. And so you got f of x times g prime of x plus g of x times f prime of x. And so you need to write either that line or this next line I'm about to write. If we're finding h prime of 2, that means you're plugging 2 into all this. So you're finding f of 2 times g prime of 2 plus g of 2 times f prime of 2. I need to see one of those two lines. I had a couple that I've looked at so far where you got the right answer for this, but your work is a mess. You don't list what the derivative is. Then you plug in some pieces before you've actually even taken the derivative of others, which makes it inconsistency there. So I can live with it if you only do one of these, but at least one of these needs to be listed where you're showing where you took the derivative. So then the f stuff we're going to find from the graph. Okay, so it's asking for f of 2, and we got to have f prime of 2. So from this graph, what is f of 2? Okay, f of 2 is 1 because that is just the y-coordinate of that point. So I'm going to write that down. F of 2 is 1. I like to list it over the side, keep everything really neat so I don't get mixed up with it. And then what about f prime of 2?
0.
It is 0 because you're going to have a horizontal tangent at that point. They wouldn't ask you for f prime of any other point on that curve. They might ask you for f prime if it was like at 5 because you could find the slope of that. But right here, you got f prime of 2 would be 0. Okay. G was the equation. We actually already found g of 2 and g prime of 2, right? G of 2 we found in the last part, it was square root of 3, and g prime of 2 was either square root of 3 over 3 or 1 over square root of 3, whichever one you want to call it. It doesn't matter. There. So we can plug in. Now, you cannot leave the answer like this line above, but you can leave the answer like this. F of 2 is 1. G prime of 2 is square root of 3 over 3. Plus G of 2 is the square root of 3. And F prime of 2 is 0. You can stop there because you have plugged in all of your values. The only thing left to do is addition or subtraction. Now, it's not very difficult to simplify. This would just be 0. So you'll get 2 times the square root of 3 over 3. So 2 square root of 3 over 3 would be H prime of 2.
2 over square root of 3 is okay, right?
2 over square root of 3 would be fine as well. Because this would be, you could also use a 1 over square root of 3 there. So 2 over square root of 3 would be okay also. Just depends on which one you're using there. And since it's calculator active, you could get the decimal equivalent since it is calculator active. But again, this is a problem that I have made calculator active because some of my numbers are hard to do. But I would prefer for you not to do that. Okay, D. D should look familiar to you from yesterday. Okay. Here is what D is asking for. Okay. F of 2 plus H minus F of 2 over H. That looks an awful lot like my limit definition of a derivative. And actually, there's one other way it might be written. I think yesterday it was written more like this. Limit as x approaches 2 from the right of f of x minus f of 2 all over x minus 2. It could be either one of those. Okay. Your limit definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. That's the one we see printed here. Or if it looked like this is the one you saw yesterday. That is this is f prime of x. This is f prime of a, where you're actually plugging the number in. So this would be the limit as x approaches a of f of x minus f of a all over x minus a. It is not asking you to do that limit. It is asking you to recognize what that limit is and then look at the graph and tell it. So this is limit definition of derivative, but I don't have an x here. What do I have instead? A 2. So that means they've plugged in 2 for my x's here, which means that I is asking for the derivative from the right of f of x. Okay? A way you can show that is you can say that this is the, limit as h approaches 0 from the right of f of 2 plus h minus f of 2 all over h equals the limit as x approaches 2 from the right of f prime of x. So it's your derivative from the right side at 2. Okay, so if we go look at our graph, I think I meant for this to be 3, actually, on this problem. Let's change that 2 to a 3. I think I meant for that to be a 3, because it makes more sense what I'm asking. You can do it for 2. What's the derivative at 2? The derivative is 0 because your tangent line is 0. So the derivative, if it was 2, would exist and it would be 0. Both of those would, I think I meant for this to be 3. These problems are so hard to make. Let's change it to a 3. Because it will be really the question I was meaning to ask you. So let's make that a 3 right there. And that's a 3. So if I look at my graph, what is my derivative from the right? -1, right? It's the slope of that line, and from the right side, it is -1. So this value right here would be -1. This stuff right here is all you have to write for part I. The other stuff I was just trying to explain it, right? So you're saying that that limit is the derivative from the right at 3, which we can show by using limit notation. That equals -1. What about the second part? What does the limit as h approaches 0 of f of 3 plus h minus f of 3 all over h? What does that equal? Okay, it's going to be does not exist. What is it equal to in terms of derivatives? It is f prime of 3. Okay, it's not from the right or the left because it's not got a plus or a minus behind here. So this is just straight limit f prime of 3. Up here, we were only coming from the right, so we had to use that limit notation to show we were coming from the right. That's the only way we know how. Although there's a chance you might get away with saying f prime of x or f prime of 3 from the right. I don't like that, and I'm afraid it might not get credit. But if you had done it on the test yesterday, I probably would have given you credit because nobody was getting this very much except for a couple people. So if it doesn't have a plus or a minus here, this is just a straight derivative. And at 3, does our derivative exist? Why not? It's not vertical. What problem do you have? A jump in the graph. So f is not continuous, and if you're not continuous, you can't be differentiable. So you would say does not exist. Because f of x is not continuous. At x equals 3, and therefore is not differentiable. At x equals 3. So if you run into something like this, where you're seeing this limit, and h's, particularly h's, right? Or this like form where you got like an f of something minus something else, it's a derivative. It's asking you limit definition of derivative, and you don't have to be able to do the limit. You have to recognize what it is and explain whether or not it exists.